So have you ever wondered why you might have a sore back after driving in a car for a couple hours? Well, what you're experiencing might be due to vibration. So in my session, we're going to talk about how can you prevent injuries from vibration, what are the risk factors. Thanks to everyone who's joined this virtual Soapbox Science. As I said, I had the privilege of doing this event at the Harbourfront before, and as someone alluded to, if you'd come to my event before, I had all these hand-painted rocks that were free for the kids to take. So today we're going to be talking about vibration, and we're going to be talking about the shake, rattle, and roll. And as I alluded to in the opening, not all vibration is good for you, and we know that vibration can lead to health effects. So exposure to what we call whole body vibration. So if you're sitting in a car, if you think about the drivers of the big heavy equipment, so this is a mining vehicle, normally much larger in size, your dump trucks, any of your construction equipment, that exposure to vibration over the course of many hours in a day, and then many days, and then many years, can lead to back problems, neck problems, gastrointestinal tract problems. When you think about, again, construction workers that use power tools, so things like this drill, mechanics, even hobbyists, some of the vibration that you get that comes into your hand can cause what we call hand-arm vibration syndrome. And that's a very serious debilitating occupational disease. It can cause the blood flow to your fingers to be restricted. It can cause tissue death, and it can cause damage to your nerve supply. And in some cases, it can actually lead to tissue death such that you will need to have part of a digit amputated. And we'll work with occupational health physicians to understand this. There you go, is the picture I wanted to show you. For the feet, you can also get tingling and numbness in the feet and get what's called vibration-induced white feet. And this can happen in, again, construction workers and miners. And we're starting to see in the high-speed trains. So we worked with some colleagues in Europe, and in Japan in particular, they're having passengers that are now complaining about tingling and numbness in the feet. So what can we do about it? Well, at our lab, we're fortunate to have what we call a vibration rotopod. And so we have the ability to measure vibration in the field with small accelerometers, and then we can replicate that on a type of robot within the lab, and it's called a rotopod. And once we replicate that vibration, we can then test all different types of materials, different seats, different types of boots, different types of materials that might attenuate or damp that vibration. So I'm going to try to show you a short video where it talks about shows our vibration rotopod. So we'll just fast forward.
Research will bring that issue back to the lab. In terms of measuring the vibration, we use what are called triaxial accelerometers. Those allow us to measure the vibration magnitude in each of your directions, if you like. At Laurentian University, we're fortunate. We just got a vibration shaker. It's really a rotopod. It's like a robot with a platform attached to it.
So the rotopod can simulate any vibration you put into it. So as long as you're collecting acceleration data, we can generate a code to make the rotopod replicate the movements of the field.
And once we replicate that vibration exposure, we can repeat it over and over again, which allows us to do a lot of what-if sort of evaluations in the lab. So we can feed in information that will allow us to replicate the vibration that you would feel if you were driving, let's say, in a mine underground or a dump truck on a municipal road. Let's say.
So you get a sense there. Hopefully you could see the rotopod. I would have loved to been able to show you that in the lab, but what we're able to do is by replicating that vibration profile, it allows us to do all sorts of really, really interesting stuff. So for example, mining may not be something that's as common in Toronto, but in Sudbury here, miners have to wear these really big clunky boots, and they are often on equipment that vibrates and puts the vibration up into the boot and causes that white toe that I showed you earlier. So we're working with a company in Italy that also makes motorcycle boots, and we're examining all the different materials that go in and make up the sole of the boot to try to determine the best combination to prevent certain frequencies that we know that cause damage to the feet from entering into that boot. So similar concept of redesigning seats. So if you think about yourself sitting on a seat, some seats can be better designed to reduce the harmful vibration. And so we can test those seats on that rotopod as well, which is really, really interesting. And probably one of the projects that I had the most fun with was my recent graduate student. She just graduated. And what we did is we looked at what happens to vibration exposure when you're pulling kids in bike trailers. So if you can imagine, lots of people are using bike trailers now to transport their kids, but there really hasn't been any study on understanding how are those children in that bike trailer impacted. And what Margaret was able to do is she put accelerometers on the bike trailer and on the back of the head of the child, and had volunteers drive through the city in Sudbury on paved and gravel trail. And she was able to then take this bike trailer and put it on top of our rotopod and replicate the rotopod, the vibration signal. And then we measured different types of bike trailers and different types of seat designs within that bike trailer to come up with a seat and trailer combination that reduced or had the lowest amount of vibration transmitted to the child. And she was able to share that with the parents and the manufacturers of bike trailers, and saw that it really made a difference what was the best combination depending on whether you were driving on smooth roads or whether you were driving on rough roads. So it was a really a fun experiment, and one of the first ones that was done really trying to understand health implications for kids. Since it's LGBTQ and STEM Day, and I identify as a lesbian woman, I think it's important for visibility for everybody to know that we can have scientists of all different backgrounds, and I'm quite proud to be an out scientist. And I had an opportunity last year at this time almost to go to Antarctica with 99 other women in STEM from 34 different countries. And it was a leadership program for women in science, technology, engineering, mathematics, and medicine. And we ended up being the largest expedition of women to go to Antarctica. And you can see here's the group of my cohort. It was just an incredible experience. And the reason I share that with you is there were two of us that had identified ahead of time as lesbian or queer. And believe it or not, we both forgot to bring our pride flag with us. And so we were quite devastated because, this was going to be a monumental moment. And so what Jeanette did, we got together, we had a combination, a chat, and we said, well, do you think if we asked everybody to wear a different colored t-shirt, they would all come out on the deck of the ship at the same time and we could make a human pride flag? And we're like, I don't know, we're not sure how comfortable everybody is. And not only did everyone show up, the expedition crew, some of the individuals on the ship that were, helping to take care of us, it was just incredible. They got out the survival suits because we were missing sort of the orange and yellow shirts. And so they were in the big wet survival suits. And so here's the picture from that incredible moment of making our human pride flag on the deck here out in Antarctica. So it just gives you a sense, science can take you many places. And I was, super privileged to have that opportunity. And again, hopefully for those, I saw there were some high school students on here. Just stay curious. You never know where your science is going to take you. We get a chance to work with some really interesting tools and talk to really interesting people and solve lots of really cool problems. So I'm happy to take some questions if there are any. Yeah, it really depended on a couple things. So what I can say is we were testing out bike trailers that had suspension and some bike trailers that didn't have suspension with a different type of gel seat cushion that could be added to where the child would sit. And if the parent or guardian was primarily driving over smooth roads or more paved roads, then the added gel cushion actually didn't help. Because what's important, I didn't talk a lot about it, but we measure the frequency of exposure. and every body part is more susceptible to damage at a certain frequency. And so what we found is by adding a gel pad in a rigid bike trailer over smooth roads, it actually didn't make a difference. It made the vibration exposure to the child worse. However, if they were driving over really rough or more gravel roads, like off roads, then having a gel pad add-on with a suspension system made a difference, and it reduced the transmission to the child. And then, you know, real simple takeaways for the parents. The speed at which you're driving makes a difference. So just like, you know, on a road for a car, the faster you're going, the more vibration that your child's likely to be exposed to. And so particularly if you're over rough terrain where there might be potholes, or maybe there's more ridges on the sidewalks because you're going on the sidewalk, think about slowing down a little bit, because every time you hit one of those little bumps, that's an acceleration that's going up into the child. And we really don't know the health implications to the young children yet. There have been some studies with neonatal transport where they put gel pads in to try to reduce the vibration to the very, very small neonates as they might be transported throughout the hospital. And that's probably the earliest vibration exposure that we're aware of. So we know that there's added health risks to those neonates with vibration exposure. Now they have a number of other health challenges. So this is really early on, but Margaret's graduated now. She's just finished her master's. But I'm hoping that, you know, she'll probably go out, work for a year, might come back and do her PhD. And if not, then we'll hopefully look to get another student that'll come on and continue this work, because we found some neat stuff, but there's more work to be done. As you know, science often introduces more questions. Oh, it's an excellent, excellent question. And let's see, I don't really have one of my props that I would have. It's I didn't bring everything from the lab, but here's what I can tell you is the simple answer is, if you have had concussion or a brain trauma of some element and you are exposed to vibration, there is a chance that that vibration exposure is being transmitted through your body up to your head and can cause more discomfort. So, for example, those exercise platforms in gyms that are vibration platforms, I'm not a huge fan of those from the perspective that there are warning signs on them, but like anything, often people don't read all the warning signs. And if you've had a concussion before or some traumatic brain injury, what we do know, because we've measured the vibration exposure at your feet, at your lower back, and at your head. And if you don't keep your knees bent and your body loose, you can get acceleration. So the signal we measure at the head can be 3 to 4 times. So that's correct, 3 to 4 times higher than what's entering into your feet. So it's being amplified as it travels through your body. So that means that energy is impacting, you know, the tissue. And we don't know what's happening at the neck and at the head, but certainly know that there's increased potential for dizziness, headaches, and people just not feeling well. They'll talk about that after that type of exposure. So are we talking like jackhammer drilling, or maybe mining drilling? Here I can show a picture. So if it's what I think it is, in construction or mining where people are operating drills. So here's an example of drills that they drill into the side of a mine wall, and then that drill leg attaches to a platform. So the vibration not only enters their hands, but it also enters their feet. And absolutely, we do know that vibration does travel. It's at a frequency range that we know does travel through the body up to the head as well. And so you can have, again, headaches, you can have neck problems, muscle problems, people just generally not feeling well. Some frequencies will actually cause your eyes to vibrate or your jaw and muscles to stiffen up. So we do always measure the dominant frequency because we know that different parts of the body are harmed more by certain frequencies. Yeah, it's a good question. You know what? I'm one of the members that founded the Center for Research in Occupational Safety and Health, and you know we've been really fortunate over the years. We've had a great relationship with with the mining industry and many of the equipment manufacturers. So we're seen as that third party. When we do our research, we try to come in always through the Joint Health and Safety Committee. And so the projects are supported by both management and labor. And then we always make sure that we're presenting our results back through to that Joint Health and Safety Committee first before they go elsewhere. You know, we've over the years, we've established that trust model, and our students learn in that way. We do a lot of work where we'll say field to lab to field. So where we have a mobile research lab. It's a 40-foot trailer that we custom designed that has all our cool tools that we can take right to the mine site, and we can equip the workers with the different sensors that we want to have on them to measure things like vibration and heat, all sorts of really cool stuff. And so we really get data to understand what the issue is, and then we'll go back into our lab and try to understand, okay, how can we solve that problem? And then we take the solution back to the mining companies and work with them. And so I think by working on not just identifying the problem, but really trying to help them identify a solution, we've gotten the support and trust over the years. And so it's been a model that's worked really well for us. Yeah, good question. So there are a few labs there. Some of the other researchers doing vibration in Canada. There's a group out of Concordia and IRSST in Montreal. Catherine Trask at University of Saskatchewan was working in this area, but she's now moved over. I think I want to say Sweden. So waiting to see who's going to fill that lab spot. Certainly, our lab in Sudbury is one of the leading labs from an industrial vibration exposure perspective. You've got at the University of Toronto a number of occupational health physicians that deal with the clinical side, so hand-arm vibration in particular, and how you diagnose and treat hand-arm vibration exposure. And then also University of Guelph and Western also have one of those rotopods, those vibration robots that I showed you. And so we do a lot of collaborative studies with researchers, Michelle Oliver and Jim Dickey at those universities as well. So it's not a large group, but we definitely are collaborative, and it's interesting work. So my background is through kinesiology and occupational biomechanics is the topic that I did my PhD in. So it really depends. So my basic science, when I really try to understand how vibration is transmitted through tissues, is funded through NSERC. But a lot of the work where we are in the workplace and trying to understand what the solution is, whether it be different boot design or different seat design, that's generally funded through like a workplace safety insurance board or Ministry of Labor, and it's really interdisciplinary. So in order to really get at that best solution, we'll work with occupational health physicians, we'll work with engineers, we'll work with computer scientists, material scientists, and occupational health nurses, ergonomists, biomechanists. So we find that everybody brings something else to the table to really understand that problem and try to solve it. It's a really good question. So even for short term, if you go out, once a week and you've got a 45-minute exposure, you're going to get that acute effect where you'll likely feel some tingling and numbing in your hands. Unlikely unless you have some other underlying health conditions that it's going to lead to like a vibration-induced white hand, or what we saw there where the fingers were going white. But again, there's certain frequencies, and it's that 40 to 50 hertz range around the palm, and then 100 to 200 hertz that really cause the maximal tissue damage to the fingers. Now, so that your workers who are exposed 4 or 5 hours a day regularly, so often these are your mechanics, sometimes dental hygienists as well. People forget about the vibration produced by the dental drills and the postures that they are in. So the combination of the posture and that vibration can also cause them to have risk factors for hand-arm vibration. So you're probably okay, but maybe trade off if you got a friend, a spouse, or a partner. Trade off doing the whippersnipping, because that's worse typically than mowing the lawn. It's right in that frequency range that is more likely to cause that tingling and numbness. I think really overall, it's for sure to just understand what the hazards are for any of our jobs, right? So once you understand the hazards and understand what the risk factors are. So again, if you're driving, a taxi or a bus or even yourself in driving a car long distances, if your back, you start to have more back pain and discomfort than normal, to understand that vibration exposure may be one of those risk factors. And so, you want to report early, because if you understand those risk factors early, we can get interventions in early, and you can prevent the condition from being turning into a chronic condition. And the same thing for hand-arm vibration in particular. Vibration white hand or white finger can happen usually quicker with shorter exposure. So new workers to construction industry in particular, it's really important that they understand that if they are at the end of every shift feeling tingling and numbness in their hand, they really should talk to their supervisor or their joint health and safety committee rep, because there are some things that you can do to try to reduce that vibration transmission into the hand and the fingers that are going to cause potentially that hand-arm vibration syndrome problem. And that one's important because once you have that tissue damage, it's permanent, so you can't reverse it. So where you saw those fingers there of that worker with those white tips of the fingers, that's a permanent damage. And it's worse in the cold. And living in Canada, it's cold, right? So if you start to have that vibration problem and you get cold exposure, it's worse. And there's international standards that tell us how much vibration you can be exposed to reduce those injury risks. So we can prevent it if we know about it. So understand the risks and report early, and then prevention can happen. That's a really good question. And it's a little bit more complicated, because certainly anyone in music will understand frequency. So what we'd need to do is measure the frequency of exposure. And we certainly know that there are some frequencies that are more likely to cause hearing damage, or hearing loss. There are frequencies that could also cause just general discomfort within the head system. So I haven't studied as much in terms of exposure for people who are professional, like symphony orchestra individuals. There are some research work that does happen in that area. So if you reached out to me, I could help put you in the right direction. But we would start with measuring it to understand the frequency, and then determine whether that frequency is linked to a tissue that could be damaged. Yeah, so it's not a great answer, but it's a really interesting question, and more people are starting to pay attention to it now. Yeah, so typically for most commercial flights that you would take, your passenger is, you're not, the vibration you're experiencing is not going to be harmful to you. There may be some people where you start to feel that sickness. So if it's a little bit more turbulent, that can be a frequency that then is associated with more gastrointestinal tract discomfort. And that's why some people will feel nauseous on a plane. Where we do need to be more concerned are the pilots, and not so much your commercial airlines, but some of the military aircraft, and particularly prop helicopters. I've got a colleague in the States who's the world leading expert in that, Dr. Susan Smith, and she just does brilliant work with the military in the U.S. And one of the main reasons that some of those very, very skilled pilots end up leaving is due to extreme back and musculoskeletal problems from the vibration exposures and the impacts that they get, and the really cramped postures that they're in. So it's a combination of problems. And then thanks everyone who participated, and great questions, and to Soapbox Science Toronto and Ryerson University for organizing another great event. Really had fun today.